Okay, all right. So today's lecture is kind of bonus lectures for those who have not done course on networking. Okay, because network security you can understand only if you understand networking. So this kind of difficult problem to solve because networking itself is quite complex. Networking, computer networks, if you start understanding, is very simple. But if you have no clue how it works, then it's very hard, very hard. It's full of protocols, 200, 300 protocols are there. It's kind of rules like lawyers work. You just, I hate to be a lawyer. Ever in life you get opportunity to choose my career, I will never. Okay, but ask a lawyer, then he'll say it's a beautiful religion, discipline, because once you know certain things, then you just build on top of that. Okay, all right. Let's go ahead. All right, so primarily I've taken contents from, this time I've taken from many sources. However, you can look at any of these. What's really interesting is to read these two books. This beautiful book. Now it's the 8th edition is available. Okay, and Professor Kuros has also given video courses. So video lectures are also available, okay, in the website. So please go through that if you want to learn networking. So in my opinion, it is one of the very good books written. Before that, people had a lot of difficulty in understanding how network works. And another lovely book is this by Peterson and Davey, and this book is available online for free. So if you don't understand anything, go to these resources and you will get plenty of information. Okay, and beauty about these books is start from the basic assumption that you know nothing. Basically, if you have zero knowledge of computer networks, then you start building from here, right? Okay, this book takes top-down approach. It starts with the web and goes down to physical layer. This book is bottom up, right? Starts from physical layer and goes up, right? However, both books gave right in the beginning overall top level view. Yeah, all right. So these are the contents. We'll go one by one. Possibly, some of these, right? What are the access networks? Anyone? Rohan, are you there? B20314.
Yes, sir.
So what is you use access networks, right?
Uh, so I didn't have the exact idea, but if I can
Yeah,
say,
yeah.
like, it will be the point where we from where we access, like, from the last class I can remember, like, we are connecting computers to one another. So we are
Right.
we are uh, a cluster of computer is accessing a point, like connected through a
Okay.
point. So that
Very
point
good.
can be
Very
an
good.
access network.
Excellent. So basically, you can see that there is something called core network, which ISPs, here only ISPs are there, right? Okay. Internet service provider like Airtel or Broadcom or whatever, not Broadcom, Verizon and many others, right? And there may be further, kind of international ISPs. We're not bothered about that. Now, how do we connect to that? Is access network, right? So, for example, you have AT&T's internet services. You have subscribed in your home. Then, how does your home connects to Airtel, right? So that's called access network. Part of the overall internet where you are accessing the core, right? Okay. So for example, as a user, you are just walking down the street and you don't have access to Wi-Fi or Ethernet port in your router, then you are using access network is mobile 4G, right? Like in your campus you get 4G. So this becomes access network. So look at this diagram which I have taken from Kuros's book. Okay, so we have national and global ISPs. Okay, and to that we have to connect, and this is regional ISP like Airtel, etc. Now how do we connect to that? Like your home network here, this is your home, right? Okay, and here you will have a lot of things, right? Okay, for example, refrigerator nowadays, new generation refrigerator comes with Wi-Fi connectivity. Basically from your, if you're traveling, you can control the refrigerator. Same is true for washing machines, and you know, like I don't have regular internet, regular TV connection, cable connection. I use it only Wi-Fi. Through Wi-Fi, I just watch IPL matches if I want to, right? Okay, so we don't need today those traditional technologies. For everything we have now internet. So similarly, we can connect uh, laptop either through Ethernet cable or through Wi-Fi, right? So this home network. So now here you can see is a router. Okay, and router is connecting to local regional ISP. Now are we connecting? This router is connected over what? What kind of networking we are using? Any idea? In your home, how do you connect your router to ISP? ISPs, you know, some Airtel guy will come and set up a box. Okay, and then it will connect through some cable, right? What is that cable? Have you ever thought about it? Anybody? Anyone?
Optical fiber.
Yeah, nowadays, very right. Nowadays is optical fiber, right? But earlier, just 5 years back, it used to be, you know, it could be a telephone cable. Telephone line is coming to home, then they will say, okay, I will connect it because line is already there. Okay, if it's not there, they will put a line rather than fiber, because fiber is very recent phenomenon. Okay, they will put a very thin wire. Uh, it's called Cat5 or something. Okay, and then this will be used to provide internet, because only a small portion of this bandwidth, which is only 4 kilohertz kind, 4 kilohertz, 64 kbps kind maximum, will go into voice, remaining will be data. Okay, so this provides the access network. Similarly, we can have, if you have enterprise network, like companies where do you internship, like IBM or whatever. Okay, TCS, Infi, whatever, right? They have different kind of network inside, right? So they have multiple routers in a locality. Forget about global network, their global network. So they have multiple routers, and note that there is usually one router that interfaces with ISP. Okay, and this is generally over fiber now. Fiber has a lot of bandwidth. Okay, earlier it used to be cable or whatever, right? And now when you go in the company, either you connect over Ethernet, but nowadays, what happens, a new generation of laptops from, especially from Mac and others, don't have Ethernet port. So you, or USB ports, right? So what you do is you connect over Wi-Fi. So now here, this is kind of access network, right? Okay, this is sorry, this is enterprise network, and access networks is this fiber. Similarly, it could be when you are traveling, it could be over mobile. You will find there is antenna somewhere. Okay, and then you connect to that antenna in that region, and that antenna is connected to a router. All right, so these are all access networks. Oh, just a minute. Okay. So we can see the access networks of type residential access network, institutional access network, mobile, through mobile like 4G or 5G. Okay. And what kind of technologies it uses? It uses DSL. We will discuss that. Like telephone wire. Okay, that comes to home. That can be used for internet connectivity. Just about 5-6 years back, all of us had DSL or ADSL. Even if you don't have telephone, they will pull, have this kind of wire to your home and give you also telephone box. Okay. Uh, okay, then cable, right? Cables are already there in many buildings, especially in US, not so in India. Okay, so these are the basically thick cable, like even if you have cable network at home for TV watching, right? Like all these companies, Airtel and Tata Sky, used to run these cables. Now these cables are for video communication, right? Okay, and it has a lot of bandwidth. Okay, so in US these cables were used, cable op, if there is a cable, there is always a cable operator. That cable operator, at the end, cable operator will have a lot of fiber, sorry, this cables that are running in the city. So that will work as a ISP, or that will provide internet connectivity. Okay, so part of the bandwidth of this cable is used for internet connection. Then nowadays we use directly fiber to home, and then of course we use wireless. So some of these we discuss here. Now, okay, first thing we discussed was ADSL or DSL, digital subscriber line. So basically this is a telephone line, right? Okay, so telephone line is running from central office, telephone company central office, and something called DSLAM as the equipment, access multiplexer. Okay, basically this thing that from here multiple wires are going to different homes. I'm repeating. And then this wire contains this very thin wire, is called this telephone wire. If you look at home, is very, this is an inexpensive wire. Okay, part of that. So now obviously it has a bandwidth. When we say bandwidth, it means that let's assume this is the bandwidth of the pipe. Okay, or data, simultaneous data it can transfer. Basically, what data rate it can transmit, right? So what we can do here is that using some frequency division multiplexing part of the frequencies here. Okay, we're not going to details. Part of this can be for voice, like normal telephone communication, where you can talk to anybody, and remaining part was used for data. So you can see that there is splitter here that will split the signal corresponding to your internet, and then this is voice telephone. Okay, any question? Any question on DSL? No?
No, sir.
Okay, all right. Just see whether you're still using DSL. Part of India is still using DSL, right? US actually 60-70 percent homes are still using DSL. India is quite ahead in terms of fiber being laid to homes. Okay, this technology exists only, used to exist. I'm sure it's still existing in many parts of US, where they have this TV cable company, line cables, they have cables all over city. And then from that, for example, this is a user home, like these are the homes. Okay, you will use splitter, and then something will goes to TV and remaining bandwidth will go to cable. So every wire, you need to know is that every wire that we have has capacity to transmit signal. At what speed you can transmit signal, right? And that we call is bandwidth. So whatever is capacity, like in a pipe, you can say that you can send its capacity is to carry 1 liter, say for example, per second. Then part of that 1 liter can be milk and remaining can be water, right? If you can separate that out, if you can separate this in two pipes internally, then you can send whatever you like. Similarly here, using some techniques, communication techniques like or DSP technique, digital signal processing techniques, you can part of that bandwidth can be used for TV, which is usually 5 megahertz kind. Convert this into digital would be, whatever sampling rate, and you multiply and you'll get some number. Remaining bandwidth, which is huge, can be used for cable. Now these were the technologies, right? And in India, these couldn't become popular because cable was always operated by some regional company, right? And they had no interest in internet and so on. And their network was very ad hoc. You'll run from one tree to another tree and so on and so forth. So yeah. Okay, so these were popular in US, not so in India. All right, so let's move ahead. Okay, all right. Then of course we are using wireless access networks, right? Okay, so you know this, right? I mean, you have in your mobile phone, you have now 3G, 4G, 5G, whatever, depending on where in India you are. In your campus, only 4G runs, and 5G in Bangalore, where I stay. But actually, internally, it is not fully 5G. It's 4G plus some features. Nevertheless, so all these will give you connectivity to internet over wireless. So basically, there is some radio communication happening. Radio channel is there, and on that channel, you put your IP packets. Okay, that's it. Okay, so now if you want to know about 4G, 5G, etc., you can learn about it. Another wireless access network is because of Wi-Fi. Okay, uh, in a campus you use only Wi-Fi, right? Okay, and so there must be many Wi-Fi access points. Like it's not shown here, but you know all these routers will also have antenna. Okay, so you look at in your classroom, you'll find some Wi-Fi access points. Okay, and these Wi-Fi access points, you'll see small round box somewhere in on the roof or wall. These are all cable connected. Okay, and then finally it goes to a router. All right. And this is the latest one, right? You have fiber to home. Now, fiber is beautiful, right? I mean, because and works out very well for India. And you send signal through optics, right? You have either zeros as no light, one is a light, or some technique, right? Okay, it does not have current or electricity, while all other methods have currents. Okay, or electrical current. Okay, now if it does not have current, what is the advantage of having no current? Anybody? All of you have done physics course, right? Akansha, can you tell me? Akansha Bhayekar, are you there? Okay. Akansha, please call me after the class.
So the resistive losses will be minimal, and by using light, we can achieve the higher speeds instead of the normal speed.
Yeah. See, if suppose we are sending a signal over a wire, right? What wire consists of? Some metal, and metal will have what? Inherently, it will have some capacitance, some inductance, some resistance, right? So signal, when it goes on a wire, it changes its shape. Okay, whatever the quality of wire, you cannot run a signal without it changing its shape more than few hundred meters. Okay, maximum you can think of a kilometer, not more than that. And when you are running this for hundreds of kilometers, then you have to have in between some kind of signal receiver. You will reshape the signal and resend it, or boost its power and then resend. And it's very expensive, right? While in optical thing, it just light goes off. There is no concept of inductance on capacitance, right? It goes on vacuum, where something inside a cable is vacuum. Okay, so now what happens? You have, first thing is that, and you can send thousands of such pulses of light or streams of light in that cable, right? And there is, for hundreds of kilometers, you don't need to touch the signal. So all this, after a few hundreds of kilometers, you need to reshape the signal again. All right, so all throughout you have all optical signals. So, and each strand of signal can contain thousands of waves, and each wave can contain GBS and hundreds of GBS, gigabytes per second kind of speed. Okay, the fiber that's coming to your home can carry terabytes of data if ISPs can handle that. Okay, so we have something called optical network terminator. From here you can connect your home, right? I mean, you will have a router and so on, right? And then you have optical splitter. It basically, you will multiplex signals or demultiplex signals coming from various sources, various homes. And then at central office, okay, central office is old terminology used from telephone days, but still we use it. A place where all this data is handled. Okay, there is something called OLT, which is optical line terminator. And then this basically converts optical signal to electrical signal. Then the router is there, which is connected to internet, right? Similarly, here there will be some optical to electrical conversion. So basically, you IP packet which is traveling in terms of lights will finally get converted to zeros and ones, and then of course your machine can receive it. Okay, now its beauty is that, for Indian perspective, beauty of this is that huge amount of bandwidth. Second is that nobody wants to steal it. Okay, nobody wants to steal this. Why? It's a copper, is a valuable metal. Okay, it's just fiber. It's just nobody wants it. Thieves can't use it. Also, rats don't like eating optical cable for some reason. Okay, so it works beautifully in Indian conditions. Okay, all right. So your home network is also access network, which is connected through some device, right? So there is a router. The router is connected, with Ethernet port. It will connect to directly to a laptop. It can connect to a refrigerator through Wi-Fi, and of course, there is a Wi-Fi device here, transmitter and receiver. So which will, so all devices we can connect it to this. Okay, all right. And this could be a modem. It could be DSL modem or fiber, modem, or could be anything, or it could be cable, depending on where you are, or it could be ADSL, DSL, like which uses telephone line, depending on where you are. Okay. Most of the time we are using fiber nowadays. All right. So this was the story. Of course, we are using Ethernet, like you can see thick line here is Ethernet cable. It could be Wi-Fi and so on. Enterprise network, similarly, you can see in any company it will have combinations of routers and switches, Ethernet switches, right? So what is the difference between a router and switch? What is the difference? Okay, we'll study that. Switch works at layer 2, which is at Ethernet level, local area network level, LAN level, right? And routers work at, which is main purpose is routing. It looks at IP address. When I so it switching here happens at Ethernet. Ethernet frames are switched. Now Ethernet frames will all, like IP packet, will have source and destination address, right? Ethernet address, right? And many other fields in header part. And here the contents will carry IP packet. Okay. Like in many organizations, you'll see that internal communication happens. It used to happen, right? When telephones were not in use. Like even in government offices, still, if one secretary has to send something to other secretary, he will put in yellow envelope. Whatever is confidential information, will put in yellow envelope, write the name of recipient, and then give it to his helper, and the helper will deliver it to another secretary, and then will open yellow envelope, remove it, and then use it, right? So it's all internal for internal communication, right? So Ethernet is used within an organization for communication. We'll look at that. Okay, so IP packets directly you can't put it over a wire. Directly you cannot. You create an IP packet, you cannot put it over wire. Okay, you have to just give it to some layer 2 technology for it to transport. The IP packet enjoys that comfort given by lower level things, right? Okay, like you want to send a packet. If your mother wants to send you a laddu, puts it into dabba and write your name, she can't just throw it out of home, thinking that it will go. She has to call a courier guy, and your dabba will go over various layer 2 technology. First, the courier guy may come over motorcycle, take your dabba from your home to some office. From there, it will be sorted out, because there will be many dabbas, and give it to somebody who is going on truck to other part, and from there it will go on third link to airport. It will be sorted out and then will fly to destination. So that flying is another link, and so on, right? So your dabba will travel over motorcycle, truck, maybe railways, maybe ship, maybe aircraft, and so on, and reach, and other side also similar way. Okay, so IP packets don't directly go over wire or air. It has to be carried over something. All right. Understand any question? No?
No, sir.
Okay, all right. Then we have access network for data center. What is data center? Tell me, you are doing data analytics course, data engineering course. What is data center? Anyone?
Where a organization keep their data or the copy of their data.
Yeah, but the organizations 10 years back were keeping it on just on a server.
Uh, it is especially for keeping data and optimized for storing data as in compact places.
Yeah, okay, all right, good. Okay. Um, okay. What is a cloud? Anyone? What is cloud?
In layman term, we can say that it is just an interface to fetch our data. Like somewhere a data center is made
Yeah.
and we are accessing data
Okay.
from there.
Very good. Very good. You're correct. Okay. So basically, what happens is a cloud is a virtual interface given to you, assuming you can fetch data, program, whatever. Okay. So it's a virtual interface. You'd never care, right? I mean, as long as you are connected to uh, your Wi-Fi, and then you take your Google Drive or do Google search or Google Photos or whatever, Amazon, etc. It's hosted somewhere. It doesn't matter to you whether your data is put in the server or what kind of memory and so on, right? Whenever you want, it should be available. Okay. Do you care the server is in India or in China or somewhere else, or whether your data is replicated to multiple sources or split into multiple places? It doesn't matter, right? So when we have and it's all created using a data center or multiple of data center. So what happens in data center is that see, earlier philosophy is that more powerful machine we make, more things we can do. Now we say that instead of having one particular processor, we will have, say, in a typical data center, you have about 100,000 or 1 lakh computers. Okay. And they are interconnected in a very smart way to each other. Okay. And then it has, huge amount of memory. Each comes with a memory, right? Disk drive as well. So now you have collection of these 100,000 to 10,100,000 computers in a hall. Then how do you use that? If you have a Google query, you just run it parallelly over hundreds of processors and collect the data, and get the result and then send it to user. Okay. Or you have Amazon.com running into whatever is the maximum capacity computer. It cannot run Amazon.com. You need thousands of more than a million computers to run Amazon.com. Okay, because more than maybe 100,000 people accessing it at any point in time. Okay, all right. So all this is hosted over something called data center. Now, data center design is very important. What is the network inside? Okay, is it what kind of technologies you're using? You're using LANs or whatever. Constraint is that it has to be reliable and fast. Now, what will be access network for this? It has got to be very, when this is to be connected to internet from where you can use, this has to be very thick pipe and multiple places it has to be connected, right? So those bandwidths will be hundreds of gigabits per second when these data centers are connecting to internet. All right. Okay. Okay. So internet in general, we can say uses packet switching and routing, right? These are very basic level concept, right? So we know that we are not doing circuit switching, where in circuit switching, what we are doing is that we are creating a circuit end to end, okay, between switches, and this all the resources are reserved here. So you put on a stream of data without creating a packet. It will come at the other end. Okay, you don't need to put boundaries between packets and don't create packet. You just send a stream of data. It comes. That's circuit switching. So other thing is called packet switching, wherein we said whatever data you have, even if you have your application is doing streaming, like your when you're watching IPL matches, etc., right? So it has to be converted into a packet. So take a stream of data. Okay, this is stream of data, zeros and ones. You put part of that into a packet. Of course, I'm not showing here, it can have also TCP UDP, but in payload part you put part of the data here. Say where is it going? Suppose Netflix is sending it to you, then your IP address will be there. Okay, second part of the data or next few bytes will be in another IP packet, and these IP packet travel over internet and reach to your end, your router, and your application will reassemble them and create a stream. So there is a concept, right? But note that internet works on packet. You create a packet and put inside whatever you want to, and the other end and internet doesn't say that first packet will reach first, second packet will reach second, and so on, right? So packets may follow different paths and ultimately reach to destination or sometimes get dropped in between. All right, but it is responsibility and machine to reassemble them and give it to application, and for that there are protocols like TCP and so on. Okay, so now we have seen that these are the core networks which consist of routers, right? Okay, now routers, this is the core. It has two functionalities. First is routing and second is switching. What's the difference between the two? Okay, so let me come here. Okay, so now a packet comes here. This is header and the payload. It comes here. Now it will have IP address, destination IP address. Now this node has many outgoing links. Like you when you're traveling, for an example, IIT Mandi to Delhi, and you are sitting behind, possibly sleeping, and driver is driving who is absolutely no idea in his brain what is to be used. He will take a placard and say that to Delhi. Okay, some say Saket in Delhi, something like that. What will happen then? He will go from your hostel to main gate. Okay, and there are two roads going from there. One was right, another was left. Okay, now traffic guy out there will look at, is wants to go to Delhi, he'll say, all right, take the road towards left. Now suppose the left had been blocked because of landslide, he would say, okay, go towards right. Okay, now this local traffic guy is a router here. Router has in itself all the information where, depending on destination address, where to send it, where send packet to, right? All right, so now this traffic guy knows that you are connected to some point here. Okay, so he won't say that now go for the left, then after 100 meters go right, then turn, you take a U-turn and all that, right? It won't say. Okay, because it's impossible that way, right? What will say, it has only four choices. The driver knows that turn left, right, straight, or whatever, right? So it will say now you go into this link. Now the knowledge is with the router, the way to send this packet to. Now your packet comes here. This guy will look at what is your destination address, and it has multiple links, and will say go on this particular link, and so on. So you reach to destination, right? So your driver is, assume that driver is absolutely novice, dumb, doesn't know anything, takes a placard, goes on the road and asks traffic guy. Traffic guy has a knowledge because, not because he is extremely intelligent, knowledgeable, but somebody has given the information. All these traffic guy have exchange information with each other, and then has some kind of table built into it. So traffic guy will look at the table inside, say for Delhi, turn towards right, and if one has got to Bhuntar, turn towards left or whatever, right? Okay, so there's so now similarly here we have a routing algorithm which runs on each of these router and tells incoming packet and tells the switch, internal switch, if the destination is something, then which outgoing link it has to go. Like your packet has destination as your IP address, they'll say go to the link number 2. If this is link number 1, this is 2, 3, 4, go to link. Now it reaches the second router, it will look again at this address and then decide where to send it to. Now it will say let's go to link number say 3. So each node has this routing algorithm running that fills up based on the destination address. It will fill up this table. Okay, and for so this part is called switching, when you are switching packet from one port to another port, and whole process of sending packet from one source to destination is called, just a minute, is routing. Okay, right? So now depending on switching is sending from one port to another port. Like here we have seen that from this port to some port it chooses, like port number 2. So this switching, this is called switching, and overall forming a path is called routing. Okay, all right. So you can see this diagram, you can go to slides and you will learn about it. All right. So now this path can be followed in this way. Any question? So routing is global action which is essentially determine source destination path taken by packets. And for that there is a routing algorithm, which all of these follow, right? It's a distributed algorithm. There are algorithm called OSPF, BGP, ISIS, and so on. Okay, all right. So we are possibly some of you have learnt about it. Okay, so this about switching is nothing but locally we can switch one port to another port. This is called local action. All right. So now what we do is that we have concept of store and forward. Whenever packet comes, the router in between stores that in a buffer and looks at the header and send it to outgoing port. Okay, this is called store and forward. First, like your packet that your mother sends will go to post office or courier office, right? And then they will look at it has to go. So is that putting that packet onto a table there or rack there is called storing. All right. Okay, now what will happen? It can have a lot of problems now. Now, okay, if this guy source A is sending packet is very high speed, and in between router there is a link which works at slower speed, 1.5 Mbps versus 100 Mbps, there will be congestion because this guy is throwing packet after packet while this link cannot handle so much. So there will be queues of packet. So each router will have a buffer to store those packets that are incoming. But what will happen? Now still this guy is sending it 1/10 of speed or more than sometimes 1/100th of the speed, then this guy, the buffer here will full and packets will be lost. Okay, all right. So all our packets when we travel, when they travel from your end to other end, goes through this process of in some router it gets stored and it will try to send it at fast speed, but it will be behind some packets. And if you are pushing packets at very fast rate or some other people are pushing, then your packet may be lost. All right. So queuing will happen, right? Queuing happens whenever work arrives faster than it can be serviced. You can see that queuing happens everywhere in traffic, signal traffic, right? Cars are coming at faster speed than switch can handle, right? Okay, or you go to a bank and then the bank clerk is working at certain speed and then many more people, hundreds of people come and so on and so forth, right? Bus can handle only certain amount of traffic and large number of people want to travel. So we'll see queues everywhere. And then there is a queuing delay because you'll have to wait. Okay, so packets have to wait. So a lot of scenarios are possible. So this shows one of the scenario. This is the switch. These are the packets. This is also a packet. Okay. So now this these are sources which will fill the packet. which will send packets on the queue. So these are the two links that are carrying packets, and this is switch. What will happen? Now, if suppose it does not have buffer here, in this case, you can see this is one of the good cases wherein this packet will go here, the packet will go here, and so on. So assuming there is only one outgoing link, right? And then the second packet will also go, so they'll go. There's no collision. There's nothing, right? No queuing delay. Now let's assume what will happen here. Packets are coming here, packets are coming to second link also. Now this packet, both packets are coming same time, only one can go. Now if this guy does not have buffer to store, then one packet will be lost. But each switches have buffer, right? So what will do, it will send one of the packets out and second packet put into the buffer. Okay, so we can see it this sorry. Okay, so there is a buffer here and one of the packets will go to buffer. Here in this case, this light blue packet has gone to buffer and this packet has gone into outgoing link. So this buffer will, if there is a more traffic coming from both sides, this queue will be formed, right? And note that this buffer has limited capacity. And if this becomes full, then the packet can be dropped. Okay, all right. All right. Any question? So when your packet travels, there can be a lot of delay because of it's part of the queue, and the queue will be serviced after some time. Any question? No?
No, sir.
All right. Let's take up a simple example. Substitute yourself with Alice and then you go to a cafe and you want to do Google. What are the steps involved? What protocols will come into play? Anyone?
First
What do
making
you
a
do?
connection
Yeah, you look at Wi-Fi connection and connect.
and then like making a protocol, maybe TCP or UDP.
Yeah, but that comes very at the end, right? Before that, what will happen? Let's assume they reboot your machine is fresh. You need certain
Like
things, right?
basically sending the packets.
Yeah, packets are fine, yeah, that's fine. But do you have address when you boot your machine? Do you have IP address?
Basically, if it is connected to internet, then it will have.
Yeah, but in order to connect to internet, you have to have IP address, bhaiya. Right? You need IP address, na? Who will give you IP address? You go to Nigeria and then you can't have IP address. Then IP address to you is given by your router here, right? It comes from somewhere. And router gets it from somewhere, right? So you have to have IP address. So let's look at the step. Now, how do you connect to Wi-Fi then? That's the first question. Okay. So there are a lot of protocols are there. Protocols are the rules. And then internet world is full of these rules, right? In the class, for example, we have protocol. When I'm talking, you will not talk in between. Okay, and if you have to, if it's classes are happening online, right, then you'll look for the pause. When I'm not talking, you will raise questions, right? So these are the certain rules, right? Okay, so walk into a coffee shop, open your laptop, and you want to do Google search. So Alice is here in a coffee shop. Okay, she reboots the machine and so on and so forth. So first thing is that she looks for Wi-Fi network. Okay, so your machine all the times keep shouting, searches for laptop network. It always say that does any wireless network exist? So this query goes on all the time. Okay, and if there is a known network, then it can easily attach to itself, right? So similarly, there is a Wi-Fi access point, okay, which will always say that key, look, I am here, so on and so forth, right? So let's repeat it. So your machine keeps sending, information. Is there a network? And then this access point will say, I am the wireless router. This is my SSID. Okay. If you have already joined that network, then you have already have password and so on. So it passes on to that. And okay, if the match exists, then your laptop joins the network and optionally performs cryptographic exchange. Now this is related to your course. Okay, so when you say cryptographic exchange, essentially you'll have to see that this packet exchange that will happen cannot be seen by anybody else. So you can provide security using some cryptographic exchange. For that, both have got to have keys. Now, this Google communication will go on for quite some time, so it cannot be done over asymmetric key or public key encryption. So the first thing would be key exchanges, and second thing would be creation of symmetric key encryption. Okay, obviously we'll study all this when we'll look at Wi-Fi networks. Okay, so matchup happens and laptop joins the network. Now you join this network. Now this is Wi-Fi network. This is all happening at layer 2. Okay, all right. Now you need IP address. See, you are not interested communicating with this guy. You are interested communicating with Google. Now, why should Google talk to you if you don't have IP address? How your packet will reach there? Two things you need minimum, right? You need Google's IP address and you need your IP address, right? First thing is that you have to have address, otherwise you can't receive the packets back. So now your packet will say to this guy, you know what, can somebody give me my basic configuration? What is the basic configuration? My IP address, and then some other things, right? We'll see now. Okay, but now there are many people connected like this, so this guy has got to have some address, this machine has got to have address. This we call is Ethernet address. All right. Okay, so once okay, so now for this we use a protocol called DHCP. Okay, so now if there is this router or it's connected to some other router has this DHCP information, which can give its configuration like IP address, etc., then it will respond back. So it's connected to a server and it may have all the information, right? So it will say that configuration includes IP address of this machine, okay, and then gateway address. Gateway is like access point. There is a router which is connected to internet. This router at the edge that's connected to internet called gateway. Okay, or address of DNS server, because she will say that machine will say google.com, but google.com is not an IP address. This has got to be converted into some IP address, right? Google's IP address. And for that we have something called domain name server. So this domain name server will convert whatever you type in, right? You can type say ibm.com or some website.com, has got to be converted into corresponding IP address. Okay, so all these three things are done in config when you get configuration information. All right. Okay, all right. Okay, another 2 minutes, it will close. So what will happen next? We'll go through this sequence again so that you get good knowledge, right? Okay, once you have this configuration information, then you want to know what is the address of google.com. Okay, all right. So now you will send this on internet through gateway, because first you will send it to gateway, and then from gateway this information will go to rest of the network, and then it will go to somebody who can resolve this. What is the IP address of google.com? So you will have DNS server for that. So DNS server, she will send a query that where is google.com, I need this IP address. One of the servers here will respond back, okay, that your Google's address is something, and then she will create an IP packet to be sent to google.com. Okay, and for that, and she wants to do it over TCP, so she will do TCP SYN, which we'll study later. Okay, and okay, all right, and there are many more steps, right? But how does she know that this Google's okay, first thing is that she will trust information came from DSC, sorry, uh, from address resolver that Google's IP address is correct. She sends it there. Now she wants to establish a reliable connection, right? Okay. Now reliable connection is called TLS connection. Now TLS connection, in order to establish TLS connection, she has to send her public key and use and get Google's public key, right? Because she wants to communicate with Google using asymmetric key encryption. So Google's public key is required. Now Google, now how does she verify that Google's public key is correct? So Google has to send a certificate, okay, that we have already studied, right? So in this way, so it will send the certificate, and once everything is verified, then this connection can be established. So of course I have skipped a lot of steps. Now in the next class we will start from here and go into internet architecture. Okay, what is concept layers, and then we'll start in layer 2 in the next class. Okay, all right, any question?